Hi, this is the second part of week 2 lecture. You remember in the first part, we talked about the combining and resolving forces of non-perpendicular force system. Today, in this second part, we will talk about the two force system perpendicular to each other or normal to each other. So in two rectangular force system, which mean that, as we said, both forces, the component of the resultant force, are normal to each other, like the one here. The angle between the y force, force, and x force, fx and fy, is equal to 90 degree. So in such case, we can easily apply what we call the Pythagoras rule, and you know it very well from mathematics that if you have the force F, for example, and you know that this F is has an angle theta from the x-axis, then to find out the Fx force, the Fx force here will equal to F multiplied by cosine theta. And to find Fy, the component Fy, which is normal to the x-axis, the Fy will equal to F cosine alpha or F sine theta. You have both choices, this one or that one, because either one of them it will be fine. The major major rule of Pythagoras, or major equations of Pythagoras rule, is shown in this frame. So please try to revise it because this is quite important for the next step of this course. There are many work examples in the lecture slides. Please go through them and try to solve these examples yourself so you can practice this. But as you can see, it's all like direct application. So for example, in this one here, if you know the force 8 kilonewton, then to find the components of this force, the perpendicular components, Fx and Fy, it's quite simple, because if you know the angle between the force 8 kilonewton and the x-axis, which is 49, then you can say Fx here will equal to 8 times cosine 45, and so on. So it's this direct application to Pythagoras rule. Now, other application, so many other application here. For example, this force is applied to a beam and in an angle beta. You can always, whenever you have a force acting on a point, you can always resolve this force into two perpendicular components. So you can draw x and y axis anywhere you want. So like example, this one here, you can put this is the x-axis and this is the y-axis. And if you don't know the angle beta here for the force F, then it's quite straightforward. You say Fx is F cosine beta, because F is downward, then we'll give it negative sign. If it's upward, we'll give it positive sign. So we need to agree to a certain rule. For example, here in this, the conventions here, this slide shows the conventions for the rectangular forces. So all the forces, for let's say Fx and Fy in the first quarter here, all of them positive, because y is upward, x toward the right side. So both of them positive. We consider them positive. If you go to the second quarter here, this is when we have X, same to the right, so it's positive, but Y is downward, then we give it negative sign. And for, let's say, the third quarter here, we have both both of them negative, because X to the left, as you can see, and Y downward. So both of them negative. And the last one here, we have Y upward, which is positive because we said upward is positive, but the x-axis, the fx, is toward the left, not to the right. So therefore, we give it sign negative. So this is actually the major conventions that we're gonna use. If you can stick to it, this is really good, because you will know that what's the sign of each force. You don't have to worry about the sign. Once you know that the x, the component fx to the left side, then it's negative. If it's to the right side, then it's positive. Same thing for y. If the y, fy, it's upward, then it's positive. If fy is downward, then you say give it sign negative. If you have more than one resultant force, like the figure here, this picture shows building structure, and you can see like we have huge beams here. Each beam has a certain force. So the first one has 2 kilonewton upward, while the second one has the 3 kilonewton going downward. And if we have this kind of forces, we want to find the summation, or the resultant force of these two beam forces. Then what we can do, we can take each one of them individually. I can take the first one here. This force is going upward. I can say, find the component of this force, because I know the angle here is 75, given in the figure. So I know the angle here. I can find fx of this force, which is positive. And I can also find fy, which is upward also. This is fy. And then same thing for the other force going downward. I can say this force, because going downward, the x component is going this way, and the y component going this way, downward. So knowing these details of each force, this is 3 kilonewton, this is the 2 kilonewton, and then I can apply, and I can add the forces together, the components together. So we have here 2fx, and we have also fy, but the difference here fy is negative, because downward. Here fy is positive, because going upward. So when I add them together, I need to put the sign. Similarly, for the fx, we have here positive sign and also positive. So when you add them, they will be summation, while for fy will be subtraction from each other. And then once I have the summation of these components, I can find the resultant force. In this example here, you can see that the summation of fx gives this value 2.32. The summation of fy gives minus 0.47, which means that the resultant of the y component is downward. So when I have these two components, I know these two components now. One of them is to the right side, fx 2.32. The other one is downward, minus 0.47. Now I have rectangular triangle. I can apply Pythagoras rule and find out the r. So r is equal to the under square root square of fx plus square of fy. You will have this value for r, the resultant force of these beams forces. And also, of course, you can find the angle of this force, or the angle of the resultant, if you apply the tan theta rule. So basically, this is in brief what you're gonna learn in this class. So please go to the slides and try to practice all these worked examples for the first part and the second part. And if you have any question, please do not hesitate to contact me or to contact your lecturer, Surajul. Thank you for listening, and I hope you will do very well in this unit.